Hey friends, welcome to AI with Supreet. And in this video, what we are going to discuss is the hottest topic on internet right now. If you are someone who is working on AI applications or who is enthusiastic about what is happening in AI, you already know that MCP servers is the next big thing that is happening. People are talking about it, and I wanted to explore it. I did that over last few days, and I have some understanding of it that I wanted to share. Please let me know what you think of what I am trying to share here at the end of the video or in comments, and let me know what you think about it. So, before we start, I want to give you a very small understanding of what MCP is, in my opinion. In my eyes, how do I see it? So, for example, we have REST APIs. REST APIs are a standard, correct? Um, what is meant by REST APIs being a standard is that how you create REST APIs or how you consume them with REST API clients is universal. Doesn't matter. Of course, the implementation could be different. I can implement my REST APIs differently than how you want to implement it for your services. But there is a general set of guidelines that we must follow in order to call it REST APIs. And for every REST API out there, we can create REST clients. There are REST clients that we can use to consume these REST APIs. So there is a standard around it, right? And that standard, REST API standard, has helped us a lot to create web and mobile applications for last I don't know so many decades. But that standard was great for that kind of an application, web application, mobile application with all UI on it. With AI, the the new UI is either conversational or voice. You will see less and less of buttons and text boxes and grids and paginated items. No, perhaps you will see a lot of chat GPT like interface, Claude like interface, wherein you have a conversational user interface wherein you are able to converse with your data, ask it questions and get the results back instead of having report builders or stuff like that. So this conversational UI or natural language UI, the standard of REST API to connect with the underlying data sources does not fit. This is where what Anthropic, the parent company of Claude, the AI, did is they come up with something called Model Context Protocol. So Model Context Protocol is nothing but it's a standard, a new standard that allows you to write AI applications with Model Context Protocol and speak with a different kind of data sets underneath it, be it your SQL databases, be it your APIs, be it unstructured data. All of that you can use, and on top of that you can have your MCP servers, and your application will become an MCP client, just like in the REST API example. Your applications uses REST clients the same way. Here you use an MCP client or create an MCP client to consume MCP servers, and MCP servers are nothing but they are the bridge between your AI first applications and the data sets available out there. And the data sets could be tables, databases, and even APIs, right? So that is what my understanding of MCP is. With that aside, I want to focus on this video today why I think that the approach of using MCP servers and clients on your AI applications is far better, it's far superior compared to what we had up until last year, which is called function calls or tool calls. So just a primer on what the function calls were. Every LLM that we use, most of the LLM that we use today, they have this standard of providing something called function calls or tool calls. Now, what are function calls or tool calls? It's a way for the LLM to identify and use existing APIs, the REST APIs. So, for example, if I'm writing a weather application and I want to check what is the weather in my city today, right? I will ask in my natural language. I will ask. Let's take the example of the left hand side, the traditional direct API approach. This is the tool call approach. Here is the user. Here is the AI application that is a weather application, or let's say an application that basically integrates works with your Gmail and calendar in Slack, for example. So the user is asking, what are my unread emails in Gmail? So your AI application will figure out the intent of this request. So you will have to write some code to figure out what is the intent of the user. You'll have to process that natural language, and figure out what is the intent of the user. And based on the intent of the user, you will have to write further logic, this Gmail integration code, to figure out what Gmail APIs you need. In this case, you need Gmail search APIs. Then again, once you have identified that you need the service as Gmail, within the Gmail you need to use the search APIs. Now you will again be responsible for figuring out what are the parameters which are required for the search API in Google to function properly and give me a good result. So then, based on that natural language query from the user, you have to do first the intent analysis, second the service detection, third within the service you do the tool call detection. You use the function calls or tool calls to figure out what API needs to get called, and then fourth whether to call that API, do I have sufficient data or not. And if you have all of these pieces together, then you actually call that API and then get the results back to your AI application and then perhaps show it to the user. But now let's say if the user says that, am I what is my availability like tomorrow? Am I free between 5 and 6 p.m.? Then of course the same thing will happen. You will do the intent detection. Via intent detection, you will understand that okay, the calendar integration is needed. And in the calendar, I need to check the call API call called availability. And then I need to check the availability between 5 and 6 p.m. tomorrow. So then what happens is you are responsible for writing all of this logic. You go to the calendar API, figure out that you are available, and then you let the user know that you are available. Then the user says, okay, fantastic, I'm available, that's great. Book me a meeting with Mark and send him an invite email. Now you have to go back to the calendar again. The intent changes this time to create an event. And then once the event is created, you also need to send an email to Mark. So both Gmail and calendar APIs may be required in this example. But what I'm trying to say here is that in this case, your code is fully responsible for writing all of this logic to integrate with all of these services, to check whether they are authenticated or not, to maintain the session and the history and the context, and also to transfer the data from one application to another, and finally also to process the data that you get back from these APIs or the integrations in a humanized form or in a natural language form and then show it back to the user. So you are responsible for a lot of things that you do when you are using function calls or tool calls and working with REST APIs in your AI application. That is what the left side architecture tries to depict. So, and again, let's go through the boxes. You'll see that a lot of custom code is required. Each API call is isolated. They are not connected. If I'm calling a Gmail API, getting some data back. If I'm calling second Gmail API or a calendar API, these are two or three different calls which are not connected at all, which are not interconnected. They are stateless, as you can see, because the second Gmail call does not have any information of the first Gmail call or the responses that I have received. It is the responsibility of my code to maintain that state. By default, all these integrations or the tool calls that we do are stateless and there is inconsistency. So you are responsible for building the context, you are responsible for building the authentication, error handling, state management, all of that. But with model context protocol, what happens is that you don't have to worry about a lot of these things. They are taken care of automatically by MCP servers and the clients. How does it work? So let's change our architecture a little. The application remains the same. Now, if you look on the right hand side, what we have done is instead of our code directly integrating these APIs, we have introduced an MCP server layer in between our application as well as the external APIs. And that changes the game altogether. In my experience, when I was using direct tool calls, the success rate of what the user was asking and what the results we were being able to fetch for them was somewhere about 30%. Because there were a lot of edge cases. For example, if I say, give me all my unread emails from Gmail, that's a totally different query than if I say, give me all my unread emails from Gmail today. These are two different queries. And because I'm speaking in natural language, I can format the query in various possible combinations. And it is very, very, very difficult for me to write or to handle all these edge cases. So a lot of rule based logic had to be written in the case of direct tool calls, which makes it very complex. And the success ratio was not more than 30-35%, which means what the user was asking for and what results I was able to get back to them, only about 30-35% of it was correct. Remaining was little vague, sometimes not having enough information. That too after a lot of code, custom code, to maintain the state and make sure the services are connected and all of that. This all changes with MCP server. So on the right hand side, what we have done is we have introduced an MCP server layer to our architecture, or to our architect diagram. And then what happens is in here, MCP server, as I said, is nothing but a standardized way of using underlying databases to connect with your AI services. But it is not only that. It not only standardizes the way you connect with your datasets and let AI speak with your datasets with MCP server in between, it also manages the states automatically. So the API calls that you are doing via the MCP server to the external integrations, in this case Gmail, Calendar, or Slack, are not stateless. They are stateful. They are aware of what was the query that was posted earlier before this and what was the response that was received. So it is aware of that context. And because it is aware of that context, it's very easy to write AI applications on top of these MCP servers, which feels a lot more natural. And in my case, the success ratio in here have gone from 30-35% to upwards of 90 plus percentage, right? MCP servers, another thing with MCP servers is, after speaking to some people, I understand that people have this notion that MCP servers will have to come from the underlying vendor, in this case Gmail or Google for calendar API or Slack. You know, if the official MCP server, when it is available, that's fantastic. But when the MCP servers are not officially available, it does not mean that you cannot use them. You can spin up your own MCP servers, and it's not very difficult. Anthropic has given us a standard blueprint of how to create MCP servers, and you can use that blueprint to create your own MCP server. So in my application, I did create MCP servers for Gmail and Calendar and Slack, hosted on my own server. Of course, I can host it wherever I want, any cloud services. There are dedicated cloud service options available as well, wherein MCP servers can be hosted. So yes, there are options available wherein ready-made MCP servers are available, created officially or by third-party companies or vendors or developers that you can use, of course. But if those are not useful or you want to change something, you can spin up your own MCP server as well, right? And the biggest benefit of this is that when I'm using MCP server, the MCP server takes care of all the natural language to intent detection. It will figure out automatically. Then once the intent detection is done, which API to call, it will figure that out automatically. Once it has figured out which API to call, whether the required parameters for calling that API are available or not, and if they are available, then call the API, get the data back, show the result back in a humanized format in natural language to the user. All of it is taken care by MCP servers. We don't have to worry about it, which means the edge cases, what are my unread emails today, or what are my unread emails, I don't have to worry about it. As long as the prompt is good with the LLM, the MCP server is able to take care of that automatically. All right. So with the help of MCP server, what happens is it's all standardized, it's context aware, it's state aware, it is consistent way. If I do an integration with, let's say, Google Drive, I can literally copy paste that MCP server implementation and do another integration with Dropbox, but just by configuring it a little different. Because it's a new standard, because it's a similar standard, I can reproduce, recopy, reuse that standard to integrate with other services. So integration with different services with MCP servers is an ease. The error handling is also an ease with them, right? So this is the difference between why I think that up until last year, tool calls were the only option to work with external data or datasets or APIs. But today, I think if you have MCP servers, it's a great idea to add an MCP layer in between your LLM applications and the external services or the APIs or database that you're using. And you will start enjoying faster results, accurate results, And in fact, I think the code will go down. The number of lines of code that you have written will drastically go down. Okay, so that's what my understanding of how where we should use MCP and how to use MCP servers today. But what I have done is I have jotted down seven very clear distinctions which talk about why MCP servers are better than using direct tool calls, and we want to go through that. So let's go through that. And we have discussed all of these 7 points in brief, but I want to touch base very quickly. So, context management. What is context management? Let's say that if you ask when is my flight and what is the weather at the destination. Now, in the tool call scenario, you need at least two different calls. One to the weather service. Once you get the data back from the weather service, then you need to oh sorry once you call the flight service, then you get to know the destination, and then you are responsible for getting taking that destination and sending it to the weather service, and then figuring out what the weather is, and then again you are responsible for humanizing the results and sending it back to the user. So you are responsible for all of it. Again, the flight service is unaware that there is a weather service. They are both not aware of each other. The API calls that you make to the flight service are independent to the API calls that you make to the weather service. And because these are all stateless or independent or isolated, it is your code's responsibility, your responsibility to connect them together. The chances of error in this goes up. A lot of management is needed. But when you introduce MCP servers, you ask the same question, and the MCP server retrieves your flight info. It identifies your destination. It retrieves your flight info from here. Let's assume that this is flight information. It retrieves your flight information, takes to the MCP orchestrator. MCP orchestrator in this case is nothing but another MCP server. That MCP server then understands, based on the user's original intent, that the user not only asked me for the destination of the travel, but they also asked me what is the weather in the destination. So now the MCP orchestrator, which is an MCP server that you have written, a custom MCP server that you have written, will figure out another MCP server called weather information. It will pass information to that, call that API, get the data back, humanize it, return the data, right? So you don't have to worry about it not having that context. The context management is automatically done by MCP servers. The same goes for natural language translation. In case of tool calls, you are responsible to process the natural language and convert that to a query language if you are working with SQLs, or figuring out which API to be called if you are using function calls, and function calls in turn use the APIs. Then you are responsible for figuring out that natural language processing. You have to write specific code for doing that. And with MCP servers, you don't have to do it because MCP servers automatically translate the request into appropriate search query parameters and the languages. So you don't have to worry about it, right? Sorry, one second. Yeah. The third one is state management. Just like the tool calls were isolated and stateless, and MCP calls were stateful and they are aware of the state, aware of the context. The same way, the state is also being managed by the MCP servers, but in the case of tool calls, direct tool calls, they are stateless. So, again, to give you an example here, in the case of tool calls, if I say book a meeting with a team member next week, my team next week, then you need to check the state across finding team members. You first go call an API to figure out who are the team members, who are the recipients that you want to book a meeting with. Once you have identified them, then you call the availability APIs for all of them. Then you need to maintain all of that record somewhere in the memory to figure out who is available on that particular time slot, or what is a common time slot wherein everybody is available, right? You are responsible for maintaining all of that state. And then finally, you are going to make a third API call to book a meeting with all those recipients on that specific time. Get the JSON results back. In most cases, you will get JSON results back from your APIs. Then you are again responsible for humanizing it and sending the results back to the user. And in case something goes wrong, you are responsible for doing error management, and you will be responsible for figuring out how the fallback scenarios will work. In the case of MCP, again, you don't have to do any of this. The MCP server will maintain the state of the booking process across all steps automatically. It's only some configuration that you need to do under the blueprint of how the MCP servers are created. So there is a blueprint. You just follow that blueprint, and you'll be able to create stateful MCP servers which are aware of the state. The same goes for authentication complexity. In the tool call scenario, you must implement your own OAuth flows, the token storage, the refresh logic. One service that you call where the user is authenticated and the token is available, it's not expired, that's great, you will get results. But now you get the results and you call another service for which the authentication has expired. Now you are fully responsible of figuring out how to deal with that situation in the tool call scenario. But with MCP, once the authentication is done, the MCP servers will figure out how to handle the token management behind the scenes. So you don't have to worry about it, right? And if, let's say, for some reason, one of the API calls or one of the third party integration that you are using with MCP servers do not respond appropriately, you end up on an error. That error handling, which is my next point, point number 5, is also being taken care by MCP servers. To give you an example here, 404 is not found error, right? 403 is something else. I think it is forbidden, 405 or 403. But then how I use 404 is, I should use 404 as not found, but it is not necessary that everybody will do that. So, for example, one API that I'm calling might handle 404, 403 errors differently than the other API that I'm using. That API might use 404, that might handle 404, 403 differently. And because of this differences on how the underlying APIs are written by their own providers, I am responsible for doing error handling separately for each of those integrations that I am writing. But with the case of MCP servers, there is a very common standardized way of error handling and fallback scenarios. So even if they have used different error handling mechanisms, it all boils down to the MCP server. In here, the error handling is done in the same way for both of those integration services. So for my application, it becomes really very easy to tackle this error because I am only dealing with one type of error handling that is maintained by my MCP servers across the integrations that I'm doing, right? Contextual memory, again, for example, if I say that, am I available, what is my availability like tomorrow between 5 and 6 p.m., and the tool call figures out that I need, the intent is to go to the calendar API, figure out whether I'm available tomorrow 5 or 6 p.m., and let's say I am available, and then in the next follow up query or command, I ask my LLM application send it to John. Now again, I am responsible, my LLM application is responsible for figuring out what it means here. It is the previous output that I am available 5 6 p.m. tomorrow. It is my responsibility in the call scenario to figure out what is it, to maintain that context. But with MCP, you don't have to worry about it. So MCP server automatically resolves the it based on the conversation history and the context. So again, fantastic because it has that contextual memory in it. Then consistent across all the services. So as I said, MCP servers are nothing but a new standard. It's a standardization of how you use third party datasets or APIs or any kind of data with your AI application in a standard format. So because it is a standard, it brings that much needed consistency that was not available before MCP servers, right? So to give you an example, I have given you this example earlier that if you add Dropbox already in your application, but now you want to support Google Drive as well, you need to learn how the API integration for Google Drive works. What are the different APIs for Google Drive? How do they work? What are the error codes? How do I handle OAuth? All of that. Again, but with MCP server, what happens is adding a new server, because it follows the same integration principles and patterns as you have done for Dropbox, you can literally copy paste, change some configuration, and you have a Google Drive integration available as well. So those were some 7 examples that I wanted to share with you, which are clear differences on why I think, in my opinion, that if you are writing an AI application today, you should start using MCP servers. If you are using tool calls, fantastic. If they are working for you, that's great. But I'm confident that if you use MCP servers along with what you already have, you will start seeing better results. You will start seeing better natural flow of users' queries and the responses and the error handling and all of that. Your applications will start feeling much more natural, and you don't have to work for the edge cases. You don't have to write the rule based logic to handle the edge cases. You don't have to do all of that, right? Finally, I want to discuss this one example here. In the tool call scenario, if I say find emails about the budget meeting and put them on my calendar, then what will happen is in step number 1, the system will say figure out what is the intent, right? My application here, the user says what are the find me emails related to budget and put them on my calendar. So the application figures out what the intent is as the step 1. Then step 2, construct a Gmail API search and query with specific parameters. You go to the Gmail integration code, custom code that you have written. This guy is responsible for figuring out what API should I call in Gmail and whether I have the required parameters or not. And if it has all those details, it will call that API. On the third step, what you are doing is you are making an API call to the Gmail. On the fourth step, you get the raw response back from Gmail. So your response from Gmail has been returned to your AI application on step number 4. Step number 5, you extract the meeting details manually. So from the response, you process that response here. You extract the meeting details from it as step 5. And step 6, you construct calendar API event creation request. Then what happens is you go to your calendar integration code and ask it to get prepared to call calendar API to create an event. Step number 7, you call the calendar API, pass on all the data related to the meeting that you received from the Gmail in the first step. And then step number 8, you get the response back from the calendar API. Step number 9, you humanize it and then you show it back to the user saying that the meeting is booked. A lot of steps involved. And again, these are all isolated. So you are responsible for everything in this entire process. In order for this entire process to work, you are responsible for all the steps in it, right? Wherein what happens in the case of MCP servers? The same question, find emails about the budget meeting and put them on my calendar. So the system sends an intent to an MCP orchestrator. In this case, the system sends the request as it is without doing the intent analysis, without figuring out what the intent is, what API services is needed. It will send that all to the MCP orchestrator. MCP orchestrator in this case, in my case, is an MCP server, a custom MCP server that I have written. This MCP server is responsible for figuring out what the intent is. Once it has figured out what the intent is, it automatically sends that data to another MCP server called the Gmail MCP server. That Gmail MCP server is now responsible for figuring out whether I have all the required parameters or not. And it's very easy. Writing the code for these is very easy compared to writing all the rule based scenarios on the left hand side for the traditional direct tool call approach. So once the Gmail MCP server is triggered, it calls that Gmail API, gets the data back, and sends to the MCP orchestrator. Now the MCP orchestrator has that meeting data. Now it again automatically on its own, because the request is not yet completely fulfilled, it will call the calendar API, not the API directly. It will call another calendar MCP server that I have written. That guy will do its own job, figure out what calendar API is to be needed, whether I have all the required parameters or not, automatically on its own, and call the calendar API, book the meeting, get the data back to the MCP orchestrator, which is also humanized automatically, and then we tell the user that your meeting is booked. And these are all stateful, which means if the user now says that send a note about this meeting to the Slack channel, then this guy will automatically be able to do that because it is aware of the historical context. It will simply pass on that new request to the Slack MCP server that we have written, and the Slack MCP server will automatically call the Slack API and return the results back to the user saying done. So what I'm trying to say here is that model context protocol actually are a very useful standard that is now available. So if your applications are relying on tool calls and function calls to use external APIs or the databases or any kind of data sources, I think it's a very good time to start exploring how adding an MCP layer can help enhance the output, the performance, and the overall natural flow of your AI applications. I hope this was helpful. For more such videos, please follow. Thanks. Bye.